Okay, let's start making some enemies. In the game, that is. So let's go to our external folder where we have our images. And let's bring in our first enemy. It's just going to be like this puddle. Now, this is going to have to be a prefab. So we take the image, put it into our hierarchy. And the size looks about right. Looks to be, approximately the same size of our player plus the weapon. So we are going to put them as order 1 in the layer, so that way they're on top of the floor. We're going to add some physics. So let's add a rigid body 2D, give it 0 gravity scale because we're going to need to move this thing around with velocity, because it's going to pursue the player. Let's also add a circle collider, and let's kind of move this out of the way now so we can get this right. So when making the collision field, for want of a better time, whether it be a collider box or collider circle, you want to make sure you aren't too forgiving, but you aren't too restrictive. So depending what you're looking to do, some margin of error. So let's shrink this down. Now, because of the uneven size, it's a little bit more difficult to get it just right. So let's see. Let's move the center over a little bit. Not perfect, still a little bit too much space there, but we can always take steps to work on that later. Now, the main thing that we're going to need, since this is such a simple game, you're really not going to have any kind of complex AI. We simply aren't able to do that. What we are going to do is basically a very rudimentary AI, and really all you're doing is you're just resolving the X and Y coordinates. In other words, the script on the enemy is going to look to see what its horizontal and vertical coordinates are versus the players, and it'll just change it by a certain amount every frame. So as far as that goes, that means we need to be able to capture the coordinates of the player, which happens to be the coordinates of the camera, which we already do. We do that with current center. Now what you can do is you can actually extract the X, Y, and Z. Sorry, looking at the wrong one. Right here, current center. Well, actually the X and Y, sorry, no Z necessary. You can actually extract the Y and the X out of that separately, so that you can do, so you can resolve the difference and make the enemy move towards the player. So let's create a script, and we'll just call this enemy control, because it's possible we'll use this on more than one type of enemy. Now for enemy control, so to compare the position of the enemy versus the position of the player, we'll have to make one quick change. So we've been tracking current center for a while now. We're going to have to turn this into a static. That way that is available to any object anywhere in any scene, which is what we're going to need. So let's save that. Let's go to our new enemy control that we created. And now, just as there's current center there for the player, we need a variable, although this doesn't have to be static. We need also a vector 2, and this will be enemy position. And what we'll do is every round, enemy position is going to be equal to get component transform position. And since we've already said it's a vector 2, it should automatically ignore the the z coordinate. So with every frame, we're updating enemy position to be equal to the position that this enemy is attached, that of the object this script is attached to, which happens to be the enemy. And what's great is if this script is attached to 20 different enemies, because this is not a static, each one of the scripts will indeed separately track the individual enemies, and we can take a look at that in a minute. Okay, so this is where the magic comes in. If enemy position, and we're going to pull out one coordinate, the x coordinate. If the enemy position x is less than current center dot x, then, oops, don't have to type then, sorry. Then we get component, and it's the rigid body, since we're going to apply velocity, rigid body 2D dot velocity. So if x is too small, then we want to bump up x, give it a 3 velocity. And we're going to just copy and paste this, just make a few changes. If the y is less than the y, then we need to change y. Now that's just one direction. It could be the opposite, because this is if x is less, and if this is y is less. So now we copy both. We need one more else in here. And this one's going to say if x is greater, then this needs to move in the opposite direction. Likewise, if y is greater, then this needs to move in the opposite direction. Now that should do it. The only thing this doesn't do is this won't bring it to a halt. So once it aligns, or should I say once it intersects with the player, it's just going to keep going. So let's, for the moment, we'll just put one final else in here. So if everything matches, then we'll make it 0, 0. In all likelihood, it won't quite match. It might actually keep bouncing back and forth. Okay, so there it goes. Yeah, see, it won't resolve down because it keeps bouncing back and forth. So if I was to be moving around, So what you have to do is you wind up creating a range where it doesn't have to match it exactly. You give it a little bit of a tolerance. And you do that by adding a second part to this. So right now this is checking for one condition. You need to check for two conditions. So I'm just going to paste this in. So because you're looking for multiple conditions, there needs to be an extra parenthesis surrounding the whole thing. And then each component is within its own set of parentheses as well. So what we were doing is we were just looking for the x position of the two variables. What we're now saying is, okay, it doesn't have to be exactly x. It can be x minus 0.5 and x minus 0.1. So in other words, as long as it's within that range, then this is done. If it's not, then it doesn't have to be. So let's take that, bring it here. Now we just have to flip this. Same thing for this. This one will type out. And less, then it's minus 0.5, double ampersand, and move position dot x less than game master dot current center dot y minus 0.1 and the extra set of parentheses, and now we just copy this. So essentially what was happening before is that it was extremely unlikely to ever be an exact match, so now you're giving it a range to fall within. Sorry about that, typo here. X, X, Y, Y, X, X, Y, Y. So X should be greater than, X should be greater than. Alright, so X is less, Y is less, Y is less. X is greater, Y is greater, Y is greater. There we go. Now it should follow me around. Let's give it a chase to begin with. Perfect. And just as an added bonus, you can see they're all resolving. We just have to fix the collision so they don't rotate around like that. Okay, so that is the very basic AI of the monsters, and we'll build on that in later videos.